Chemistry, we're on to problem 2 of the day 35 assignment on mass stoichiometry. Okay, so first we got to get our molar masses. This is our new equation. It's another combustion reaction. It looks very similar to the last one. You mix a hydrocarbon with O2 and it produces CO2 and water. This time the hydrocarbon, however, is propane, and so it has a different formula here. So let's go ahead and figure out the molar mass of that. We're going to need that. Okay, and the others have the same. So for oxygen, it's 32. There we go, and we'll go ahead and write those up here. Okay, so we'll go ahead and get started now, working on these. All right, so how many moles of CO2 are produced from 5.3 moles of C3H8? So we're looking for moles up here, and it's CO2, so there's the question mark. Okay, 5.3 moles of C3H8. So down here, or right over here rather, is C3H8, and that's 5.3. So both of them are up in the moles row. That means it's just a one conversion problem, straight across from 5.3 to the question mark, and then the two conversions are right there. You just put them into an equation. So let's go ahead first and write out our equation. We're looking for moles of CO2, so it's way over here. One conversion. Okay, so here it is. This equals this. 1 mole C3H8 equals 3 moles CO2. Okay, we need moles of C3H8 on the bottom because of that, so we'll put it down there. Okay, and this cancels. So we have 5.3 times 3 divided by 1. That's going to be, the last man standing, by the way, is moles of CO2, so that's going to be 15.9 moles of CO2, and that's our final answer. All right. How many? Let's see, we're going to try to move this back and forth. All right, let's write the equation first this time. You want to get to where you can do that eventually without the graphic organizer at all, but I do want you to use it as you need it. So how many grams of CO2? So way over here we have grams. Okay. In fact, I'm going to write it further over to the right. And the reason I said that is because we're going from grams to grams, and I now recognize that that's going to be 3 conversions. So it's from 2.23 grams of O2, so write that way over here. So let's go up there and see that on our graphic organizer. Okay, so 2.2 grams of O2, there's grams of O2, that's 2.23. And we're trying to find grams of CO2, that's over here, there's the question mark. So the only way to get from there to there is to go up into the equation. That's 1 conversion. Over, that's 2 conversions. Down, that's 3 conversions. Okay, so let's go ahead and draw 3 boxes. Didn't do that quite right. Let's do it like this. Equals underline. Okay, so first conversion has got to get us from here up into here. So that's the molar mass of oxygen right there. Whatever's between those 2 boxes is what you use. Start it way over here because these are going to be kind of long. Okay, which one goes on top and bottom? You have grams of O2, so grams of O2 has to go on the bottom. Cancel and cancel. Okay, so now we're sitting up in this box right here. We need to get over to here, so then you take it straight out of the equation. 5 moles of O2 equals 3 moles of CO2. Okay, so there that is. Okay, you have moles of O2 on the top here, so you need moles of O2 on the bottom there. And so that's going to be this one. So that cancels with that. Now you're in this box here, and you need to come down, so you need to use the molar mass of carbon dioxide. Okay, so up there you have moles of carbon dioxide, so you need it down there, moles of carbon dioxide. Grams of carbon dioxide is the last man standing, and that matches with your answer, so you have it done correctly. So it's 2.23 times 1 times 3 times 44.01 divided by 32 divided by 5 divided by 1. And that gives us 1.84 grams of CO2 right there. All right, we're going to move on, clean up our graphic organizer first. Okay, how many moles H2O are produced from 4.83 grams of O2? So moles of H2O is what we're looking for up on the moles row. Put a question mark there. 4.83 grams of O2 right there. Right there. So we need to get up and over. That's two conversions. One up, one over. Right, so our first equivalency is going to be the molar mass, and our second is going to be come straight out of the equation going from there to there. All right, so let's write this down. And we saw it's two conversions, so two boxes. Okay, first equivalency is the molar mass of oxygen to get up to here. Let me get on screen there. Okay, grams of oxygen's up here. It needs to cancel out down there. Grams of oxygen cancel. Okay, so that means we're up in this box now. We need to move over here. So the equivalency is 5 moles of O2 equals 4 moles of H2O. Okay, so you got moles of O2 up there. You need moles of O2 down here. That's going to be this one. That cancels with this. The last man standing is moles of H2O, which is in the final answer. So 4.83 times 1 times 4. Divided by 32, divided by 5. And we get 0.12 moles of H2O. Right there. Okay. All right. Okay, how many moles of O2 are consumed when 1.52 grams of C3H8 are consumed? So they're both on the reactant side. So as this is consumed, this is going to be consumed right there. All right, so I cleaned up the graphic organizer. So it's moles of O2, how many? So that's the question is right there. Are consumed when 1.52 grams of C3H8 are consumed. So the 1.52 is down below C3H8. Okay, and it's in the grams row. So we're going to need to go from here up and then over. So first conversion's molar mass. Second conversion is straight out of the equation right there. So let's go ahead and do that. And we saw it's two conversions, two arrows. Okay, so first conversion is the molar mass for C3H8. Need grams of C3H8 on the bottom to cancel. Okay, so now we're sitting up here in the box, moles of C3H8 right now, and now we need to get over, so it's going to be 1 mole C3H8 equals 5 moles of O2. Okay, alrighty, there you go. You got moles of C3H8 up on the top, so you need that on the bottom, so it's this one goes on the bottom, this one on top. Last man standing is moles of O2, so it's 1.52 times 1 times 5 divided by 44.11 divided by 1. And that gives us an answer of 0.17 moles of O2 right there. All right, clean this up, erase everything here. How many grams of O2 are needed to produce 5.67 moles of CO2? So we'll come way over here, equals some number of grams of O2 is what we're looking for. So come over here. Grams of O2 is the question mark. And moles of CO2, 5.67. Okay, so you need to get from here down to here, so it's over and down. So first equivalency is in the chemical equation. Second one going down is the molar mass for oxygen. Okay, so 5 moles O2 equals 3 moles of CO2, getting between these two. Moles of CO2 has to be on the bottom. Okay, now you're sitting in this box, you need to come down, use the molar mass of oxygen. 1 mole equals 32. Moles of O2 on the top needs to be on the bottom. cancels in that. Last man standing is grams of O2, which matches up. So it's 5.67 times 5 times 32 divided by 3 divided by 1. Okay, and we get 302 grams of O2 for that. Okay, our next question is, how many moles of H2O are produced when 8 grams of C3H8 are combusted? Come over here. Okay, so we need moles of H2O is what we're looking for. So here. And we're starting with grams of C3H8 down here. So we know you need to go up and then all the way across to there. That's 2 conversions, up and over. All right. Okay, so now the first one is going up, and that's the molar mass of C3H8. We need grams of C3H8 to cancel, so this goes on the bottom. And now we go 1 mole of C3H8 equals 4 moles of H2O. Moles of C3H8 is on the top, has to be on the bottom here. Last man standing's right there, so it's 8 times 1 times 4 divided by 44.11 divided by 1. And that gives us 0.72 moles of H2O. All right, next one, we're going to do one of the longer ones, the grams to grams. This cleared off. Okay, how many grams of CO2 will be produced when 6.6 grams of H2O are produced? So they're both on the product side. So how many grams of this will be produced when this number of grams? So grams of CO2 is what we're trying to find out. And 6.6 grams of H2O is here. Okay, so we go up through the molar mass for water to there, then across using the chemical equation right there, and then come down using the molar mass for CO2. Start this one way over on the left because it's going to be long. And we saw it's up, over, and down, so it's 3 conversions. Okay, there we go. So let's do the first one. So we're starting with 6.6, we're going up to here. There's the molar mass of water. That's your first equivalency. Start that way over on the side as well. Okay, grams of H2O has to cancel, so this one has to go on the bottom. Cancels, cancels. Okay, now we're sitting up here. We need to go over to here. So it's 3 moles CO2 equals 4 moles H2O. Need moles of H2O to cancel, so this one goes on the bottom. Okay, so now we're sitting in the box moles of CO2 up here, and we need to come down to our final answer using the molar mass of CO2. Okay, moles of CO2 on top has to be on bottom here. That cancels. Last man standing is grams of CO2. So it's 6.6 times 1 times 3 times 44.01 divided by 18.02 divided by 4 divided by 1. Okay, and that's going to give us 12.1 grams of CO2 right there. Okay, all right, one more. And it's how many moles of CO2 are produced when 8 grams of C3H8 are consumed. So let's write the equation first this time. Moles of CO2 is what we're looking for. This is what we're starting with. Come on back over here. Moles of CO2 is up here, it's a question mark, and grams of C3H8 is here. Very similar to an earlier problem. Okay, so we've got to come up through molar mass of C3H8 and over to moles of CO2. So that's our first equivalency. And we're going to need 2 conversions. Okay. All right. Okay, so first equivalency we said is the molar mass of C3H8. Okay, grams of C3H8 up there, so we need it on the bottom here. That cancels with that. Okay, now we're up here, moles of C3H8, and we need to get over to moles of CO2. So it's 1 mole C3H8 equals 3 moles. 1 mole C3H8 equals 3 moles of CO2. Okay, we got moles of C3H8 on the top, so it has to be on the bottom. That's this one. Cancels with that. Last man standing is moles of CO2. So it's 8 times 3 divided by times 1 divided by 44.11 divided by 1. And we end up with 0.54 moles of CO2. And that takes care of every problem on this assignment. So I want you to practice these and know how to do these really well.